What's up everyone, Rocket Randall here, and I'm really excited to bring you something new. I've been working really hard on getting you 3D print files so you can print your own 3D model rockets. And today I'm going to cover the first of those. I call it the Gnat. It's similar in size and shape to the Estes Mosquito with similar flight characteristics, but it's got some unique things because it's 3D printed that make it super easy to use and super easy to lose. Stick with me as I show you how to build, print, and see some flight footage. I promise you this is going to be the easiest build video you've ever seen with a rocket. There are some challenges with this, but it's not in the build process. The biggest challenge really comes with printing it. It prints in two different pieces. The main body, which includes the fins, the launch lug, and all of the stuff to hold the motor in, and the nose cone. And assembly is literally just putting some glue in here and gluing it together. That's it. It just pops together and you're ready to go. The whole idea of this rocket is that you can 3D print this rocket yourself. And my goal with it is that I wanted to make something that was free for everybody, that I could make available. You guys can print it out, try it out, and see if you like 3D printing model rockets or not. So that's what this is designed for. One of the challenges with 3D printing rockets is that there's a very tiny amount of surface area that goes in contact between the rocket and the build plate. That means as it's building up layers, the chances of it rocking loose and falling off is relatively high. So there's a few things we can do to ensure that we have a good print. The first one of these is we're going to want to use a brim. And in your slicer settings, there's a brim setting, and you're definitely going to want to use a brim. That tends to make it so it doesn't fall loose. The second one is you need a completely clean build surface. So I've got well over 20,000 print hours at this point, so I've done a lot of time printing and kind of see what works and what doesn't. And when I have prints that aren't sticking, here's what I do. If I've been printing for a while, the layer on top of the build surface tends to build up that makes it hard for things to stick. This is similar to like some rust building up, but this is like plastic bits are connecting to the PEI sheet. So I use 4-0 steel wool and give it a little rub down all around it. And what this does is it kind of roughs the surface just a little bit and allows some fresh PEI to be available for the rocket to stick to. So that's the first thing, is just give it a brief rub down with some steel wool. And the second thing is wash it with Dawn Power Wash or a similar anti-oil dish wash. Wash it really good with that, get it all over it, rinse it very thoroughly, and then dry it. Either let it air dry or dry it with a clean paper towel, and then it'll be ready to go. The big thing you do not want to do is touch it with your finger because there's greasy oil all over this. If you touch it with your finger, I promise you, the rocket's not going to stick to it because there's such a little surface area, it's going to knock loose. The other thing I'll note is I typically print with ABS. And with these ones, as a good introductory model, because there's a high probability you're not going to find them, you probably can get away with printing them with PLA. Because even if some damage happens, you're not going to find it anyway, and even if it damages, just print another one. And that's great, because the other challenge with these rockets is finding them. I have launched over a dozen of them in my tests, and I have yet to find any of them. They run on the smaller 13mm motors. I started with the A3-4T, and they went really high. You could kind of see some puffs. I don't even know how high up, but I have no idea where they came down. So I switched to this one, which is a 1/4 A, and they didn't go as high, maybe several hundred feet, but I still have no idea where they went. So print a bunch of these because you're probably going to lose some of them. And that's one of the beauties of this rocket, though, is once you've bought a roll of plastic, the actual cost to print one of these is like 25 cents. So you print it for 25 cents. It might take an hour or two on your printer, depending on how fast it is, to print one of these. Assembly takes seconds to just glue it together, let it dry. So you've got very little time, very little money invested in them. You throw an engine in them, light them up, see them go off. If you find it, great. And if you don't, that's okay, you can print some more. So if you want to try printing these and flying them, you can get them today. There's a link in the description where you can download the files for free and print as many of them as you want. They're actually pretty fun. I really want to find one time. At one launch, I launched a whole bunch of them, hoping somebody would stumble upon one in the field. And to show that, I've got some flights for you coming up. I highly encourage you to try this out. If you've got a 3D printer, download the files, print it out, see how it flies, and have a lot of fun. Keep your eyes in the sky with Max-Q rockets.
5, 4, 3, 2, 1, launch.
Oh. That was weird.
Highly entertaining though.